There we go. Had to go ahead and get the bit rate on the audio just right. All right, but we're off and away now. Now, I went ahead and did a bandwidth test. And everything looked okay to me. The bit rate looks good. All right. Hello, him, Jay. Let's see how we go here. I'm going to go ahead and keep the Twitch Stream Manager closed. It's buffering again for you. All right. That would be a Twitch problem. All right. Well, we have no packet loss. None of the other problems that we did last night. So everything looks okay. Got all of our encoding, all that good stuff. And I can see that it's also buffering a little bit in our Twitch Stream Manager, but that's all right. We're going to go ahead and just make it through. Okay. Well, hey, it looks to me like the streams... Looks like we've got good quality again. All right, so... Just to go ahead and recap. Last night, we tried to do our .NET and Scotch stream, but unfortunately, Xfinity, who... so we are currently not working out of the Pettibridge office, aka my house, working from home, because we are in the middle of redoing all of our flooring at the moment. So... Just had all of our floors leveled yesterday. They're laying down some tile and stuff now. And it's not really a good environment for us to try to get our work done while that's happening. So we are staying with a relative who happens to be stuck using Comcast. And the upload speeds we were getting from the entire network yesterday were around 2.5 megabytes, which is like 1998 bandwidth levels. So we decided to go ahead and just call it quits. Packet loss was in the ballpark of like 60% last night, so the stream was totally unusable. So anyway, we're going to go ahead and give this another try today, doing it Scotch and .NET and Scotch Day Drinking Edition. All right, so I'm going to go ahead and retweet this out here. Let me go ahead. Grab this. Ah, goodness gracious. Looks like my makeup stream didn't go live. Looks like my tweet about it didn't go live. So let me go ahead, do that again real fast. Just gotta grab my profile. Apologies for the delay, folks. Let's see. What tweet? Go ahead and grab my little URL here. All right, there we go. That's out. Hey, H3, how's it going? All right. Just went ahead and blasted that out there. And I'm going to go ahead, retweet that out. All right. Well, we'll go ahead and see what happens at this rate. You like my title, the 10:30 a.m. day drinking edition? Unfortunately, it's a little misleading. We're actually not going to be doing any day drinking because I do have stuff to do, and personally, drinking a little bit of scotch towards the end of the evening, totally down with. Doing it at 10:30 in the morning on a work day, in some countries, that's totally probably all right. I do not live in one of them. But that's where we're at. All right. So let me go ahead and get off our little title screen here. Sorry, I was doing my Twitch bandwidth inspector. And let's take a look at what we're actually going to discuss today, which is this little project that we started on last Thursday's stream. So I'm going to go ahead and add a little marker here. Last.net and Scotch. So I'm going to go ahead and add a little marker. We're going to go ahead and add a little link back to last Thursday's stream where we introduced this. So last Thursday, we tried to go ahead and build... I had the basis of a little Azure function that was built on top of Akka.net and .NET 5. We tried to go ahead and turn this into an Azure function. We tried to go ahead and build a little bit of a... we tried to go ahead and basically get started operationalizing and turning my little console application that was not yet a .NET function. We were trying to get all that up and running, and we ran into a whole bunch of problems, not the least of which was .NET Functions doesn't really support .NET 5 right now. They say they do, but it's using this whole out-of-process model, which felt a little cantankerous to me. So we ended up on the last week's stream going and refactoring everything into a .NET Core 3.1 app. And then we were able to go ahead and deploy an InfluxDB instance up in Azure using just the portal to go ahead and provision that. We were able to go ahead and also provision a bunch of other resources into the portal as well, storage account, a key vault, all the things we need to go ahead and build this app. So I've probably put about 40 hours or so into building this application. Now I'm going to drop a link to it in chat because I did sanitize the source code and make it open source. So anyone could actually pull this down and run it. I'm going to go ahead and start real quickly with an explanation of our network architecture to some extent. And we'll take a look at some of the resources inside our Azure account. And I'll talk a little bit about how we can work backwards from, let's say, building... Let me go back to my resource group in Azure here. Building up like a real production set of Azure resources and how we can export an ARM template from that and work backwards from that ARM template to help create a Pulumi application that can go ahead and make all of our infrastructure immutable. So we can go ahead and automate changes and deployments to all this code without all this infrastructure without needing to make it brittle. So we'll talk a little bit about that. We'll also reintroduce Pulumi since we didn't get a chance to actually do much of it last time around. Now, from an infrastructure perspective, here's how this KPI application works. And KPI, if you're not familiar with it, I define the term here, key performance indicator. It's a way of typically measuring business metrics such as marketing input versus output and plotting the performance and correlation of those together over time. So the way this whole system works is we have a little app service, a consumption plan, which basically means we only pay for the amount of, let's say, I think it's the megabits per second that our Azure function uses while it runs. So this is a fairly, for functions that are infrequently called, this is a very low-cost way of trying to go ahead and build an application. And then our KPI collector uses a polling methodology. It's going to go ahead and poll some third-party APIs to gather a whole bunch of metrics and bring them back into an InfluxDB database, which is where we're going to chart all of our data. So if I take a look at InfluxDB real fast, let's see, I have to refresh this here. All right, here we go. I think I set this up using Google authentication, Google single sign-on. That's what we use for all of our email and everything. We're all a Google Apps company here for that stuff. We have a bucket called KPI-DB that has, and this is important, for KPI data. So most people use InfluxDB for storing things like application performance monitoring metrics. That's kind of primarily what it's intended for. But really, it's a somewhat generic time series database. So I figured it would be relatively inexpensive for us to go ahead and store metrics that can go back much further than what your normal APM metrics might go for. So for instance, measuring the performance of, let's say, a marketing campaign or a website redesign, you want to go back much further than, let's say, 30 days. You might want to go back, 2 2 years to go ahead and measure the impact of that over time. So right now, we're only gathering metrics from a couple of sources. We're gathering it from our email marketing system and from Google Analytics. So we're measuring web traffic and also like the growth of our mailing list over time. So for instance, if I go ahead and run this, and let me go ahead and change this to past 30 days, I can go ahead and see basically that the total number of subscribers isn't really changing that much. That's because, funnily enough, right after I deployed the service, we actually migrated off of MailChimp onto a new email marketing provider called Omnisend that doesn't quite expose these metrics yet. So this data is not really changing very much. Hence why the axes are pretty narrow here. But I can also go ahead and add another query if I want to query website performance. Let's take a look at the number of sessions and views on the website. And I'll go ahead and do this for Petabridge. Hit submit. So you can see our number of email marketing subscribers up here. And you can go ahead and see basically our sort of daily plots down here of the total number of views and the total number of sessions. So these are daily numbers that we're getting out of Google Analytics. So the big idea in terms of the business value of the system is to try to help us correlate these activities over a long period of time. So that's what we're trying to accomplish. Now, it's hidden behind the chat overlay. Thank you. Let me go ahead and move that to the left then. Let me do this. I will get this right, I promise. All right, there we go. Sorry about that. You can kind of go ahead and see the plot right here of all the different traffic for all these little settings. Thanks for letting me know about that. So that's really kind of the business value behind the system, is letting us be able to go ahead and understand so let's say marketing inputs drive what business outcomes. That's the big idea behind it. So in terms of the way this whole thing's organized, it's primarily this Azure function that's doing all the work here. You can go ahead and see this Azure function's got a nice sort of, let's say, sawtooth execution graph. That's because this function runs on 5-minute intervals. One of the things I'm going to do is I'm actually going to go ahead and change this interval to be every 4 hours, because we don't need to be polling data all this frequently. And I'm a little bit worried about hitting like an API resource limit, which would actually make it a lot harder for us to get accurate metrics out of it. We also have monitoring and logging set up for this, so we can diagnose problems that might occur with this Azure function downstream. So the whole architecture for this app is pretty simple. We have our app service. That's our consumption plan. That's basically our sort of unit of billing. You can deploy multiple functions to one app service plan if you want, but they all have to be of the same type. In this case, they all have to be Linux.NET Core functions in this case. And we've got one function that runs on a timer trigger. So we specify a cron schedule for that. That writes to this little InfluxDB database. And that InfluxDB database I was looking at is actually something I bought through the Azure Marketplace down here. That's what this little SaaS object is. We did this on the last stream. That's the only resource I can't script via Pulumi in this whole sample. So I'll refer back to that a little bit later. But this is using Influx Data's sort of, let's say, serverless Influx instance. This is going to cost us maybe $1 per month to go ahead and run. And that's after we have a lot more data sitting inside of it. So it's pretty inexpensive. Next, we have a storage account. Storage account's primarily for hosting the binaries that we're going to use for actually executing the function trigger. And then also using the executing the function. We have a key vault for storing all of our sensitive credentials. So, we're talking to things like MailChimp and Google Analytics. We're going to be adding credentials for being able to talk to some other services too. We want to have a safe way of storing those. And I don't necessarily want every developer on my team being able to go ahead and access our MailChimp API key, because someone could accidentally go ahead and send a mass email to 10,000 of our customers in one go there. That'd be bad for business. So we want to go ahead and try to make it so developers can still use those credentials without necessarily needing to know them. So only someone with, let's say, privileged access to that part of our system will go ahead and enter their credentials in as a Pulumi secret. And those will get incorporated into an Azure Key Vault, which can then in turn be read by the actual app service as an environment variable later. And I'm going to go into some detail on how all that works. Finally, we're going to use Azure Application Insights to go ahead and actually monitor the performance of the system. X, can you explain why you're using InfluxDB for this? Bit of a newbie here. Sure, absolutely. So I originally submitted this whole project as a job on Upwork. We were trying to get someone else to develop it for us rather than build it in house. And the quotes I got back were astronomically high. People wanting to charge like, I don't know, $130 an hour to go and work on this thing, which just seemed a little ludicrous to me because the business value of the system is not known. So the way I probably should have priced this job is I should have done it at a fixed price. I should have said Petabridge is willing to pay $5,000 to do this. That would have probably gotten us more of the types of offers we were looking for. However, one of the things I realized after we started getting those quotes back is that part of my problem was I'd specified that the way I wanted to build this was I wanted the developers on our team to be able to go ahead and view these business metrics using a Grafana dashboard. And I thought the right way to go and expose all these time series data was for us to store it ourselves in something like Azure Table Storage, and then use the JSON plugin for Grafana to go ahead and render it as a special type of JSON schema that Grafana can recognize and can iterate through. And I realized in the course of talking to some of these developers that was actually a much more expensive way of going about it than trying to use a dedicated time series database, which is what InfluxDB really is. InfluxDB is a time series database where if I take a look at our data explorer, and let's say I take a look at the raw data here. All right, now I know you might not be able to see some of the values over here on the right. That's okay, you don't really need to. What you can kind of see here is that in this table, you can go ahead and see sort of, let's say, the time horizons for some of these values. So let me go ahead and keep scrolling here. So we can go ahead and see, all right, if I scroll up, I see at, May 14th, 2021, at exactly 1100 hours, we recorded a MailChimp mailing list size of 9504. And you can see that value keeps repeating. It's because our mailing list isn't changing that much. So one of the things that InfluxDB allows you to do, if I go ahead and take a look at our source code here, the actual Azure function itself is in this petabridge.kpi collectors.functaculous project. But the actual area where we read and write to Influx is inside our petabridge.kpi.models. And so if I take a look at, let's say, email metrics right here, I go ahead and I query a bunch of data from MailChimp using this API call. I go ahead and stick this into, let's say if I don't get any automations back, I just go ahead and log an error. And then I guess we go ahead. Actually, I really should actually go ahead and exit here. We shouldn't keep continuing with this, although nothing will really happen behind the scenes here. But I should probably just exit early when that occurs. But anyway, when we do find automations, I'm going to go ahead and iterate through all the automations that are currently sending in MailChimp. I'm going to create a new point data. This is the InfluxDB client. I'm going to go ahead and say, okay, the timestamp I want to use to record this is the current time in UTC. And I'm going to go ahead and add these tags. Think of these tags as different indices you can use for querying that data coming out of Influx. So in this case, I'm going to go ahead and add some tags here. And I can go ahead and see, in my pipeline, let's say if I go ahead and... Actually, let's take a look at the code for querying the total size of the mailing list. I think it's get subscriber stats is what I want to see. All right, well... Let's see, campaign, get subscriber stats. Here we go. So I'm going to go ahead and say, all right, point data dot measurement, email subscribers, tag list name, tag service. So I can have multiple different ways of organizing my subscribers. That's what the list name is. I go ahead and record a timestamp, and then I record these fields. Tags are indexed. So these are different searchable properties for letting me figure out how narrow or wide my query should be. And these are the data points that I'm gathering right here, each of these little fields. So I can gather multiple data points all at once. In InfluxDB's Data Explorer right here, if I go back to query 1, I'm saying I want to take a look at my email subscribers. This correlates to this measurement. I want to take a look at the total number of subscribers. That's the field. So I want to see this piece of data. And then I want to go ahead and filter based on these properties, list name and optionally the service. So that's why we're using InfluxDB. It gives us a fairly simple model for being able to go ahead and express this multi-dimensional data really easily. So once we add support for, let's say, Omnisend, our other email marketing provider, I can go ahead and basically say, okay, how many subscribers are on our MailChimp list versus our Omnisend list? And if I don't specify the service filter at all, then you should see just a pretty much straight graph of where it has Omnisend and MailChimp kind of like in one continuous line together. Does that make sense, Anx? Does that answer your question? All right. All right, good. Glad I helped. Okay. So anyway, this is what the sort of little architecture of our application looks like. Now, as for the actual function itself, I went ahead and I spent quite a bit of time working on that. So let me go ahead and grab my KPI dashboard here, open this up in Visual Studio Code. Now I have a private version that Petibird is deploying that has all of our specifics built into it. This public dashboard instance right here, if I go ahead and reload this, this public dashboard instance right here is a totally sanitized version that doesn't have any of our configuration in it. You can go ahead and pass in all of your own values to go ahead and get this up and running yourself. Whereas the one I'm taking a look at is the one that has all Petibridge's values in it. So this is actually, let me go ahead and close all those other tabs. Don't save. All right, there we go. Now, if I go ahead and I scroll down here, I have, let's see, I wanted to go ahead and take a look at the actual Azure function definition itself. That'd be right here, KPI collection. All right, so our Azure function is pretty minimalistic in terms of the source code here. I go ahead and I define an Azure function name using this attribute. I specify a timer trigger for it. And this timer trigger, the way it's currently configured, this means using the cron syntax. And there's you can go ahead and essentially look this up in the Azure documentation. This is a pretty standardized syntax for all cron jobs. This specifies run this job once every 5 minutes is what this means. One of the things we're going to go ahead and change is we're going to change this to run once every 4 hours or so. And then we go ahead and we take this Akka service as a service dependency, and we just call run async, and we await that. Now the Akka service itself is going to go ahead and take a dependency on an iService provider behind the scenes. This is the standard interface for doing dependency injection in .NET. So I'm going to go ahead and take a dependency on this. And then I'm going to go ahead and return a little task with this run async method here. We're going to go ahead and create a new actor system. And we're going to pass in this dependency injection setup along with this Hocon configuration. This Hocon is just basically telling Akka.NET to go ahead and use the new internal dispatcher type that we created. This is kind of experimental syntax from Akka.NET 1.419. It doesn't actually really do much for this application since we're only running a very short-lived actor system. But nonetheless, I wanted to try it out anyway. And then after we create our actor system, we're going to create a couple of actors. I'm going to create a marketing coordinator actor who's going to be responsible for starting our web analytics and our email marketing actors. And then next, I'm going to go ahead and create a work coordinator actor who's going to monitor the marketing coordinator actor. And then we're going to await on this task that gets returned by the actor system. This task completes if and only if the actor system shuts itself down. So the work coordinator actor's job is it maintains a hash set of actor references, and it's going to go ahead and decide to death watch all of these actors. That's what context.watch does. We get a little notification back when one of these actors terminates. And every time an actor does terminate, we go ahead and we remove that actor from our hash set. And then when the number of actors in the hash set drops down to 0, we terminate our actor system. That'll go ahead and cause this task to complete. That'll cause the Azure function to go ahead and exit successfully at this point. Now you might be wondering, all right, well, where does all the MailChimp and Google Analytics and all that good stuff show up? Well, one of the things I did after the last stream is I went ahead and decided to go ahead and use a startup class. So this is similar to the startup class you'd see normally in like ASP.NET Core, but this time we're inheriting from a specific base class, this function startup class. And so we get a function configuration builder and a functions host builder. So this is stuff you have to do when you're not doing an out of process Azure function. You have to have a little bit of trim to your application that kind of looks different from a traditional .NET Core app. So all I'm doing here is I'm basically just saying read in environment variables. Honestly, this probably isn't even necessary. Azure Functions already has the ability to go ahead and be configured via environment variables like this. But I just wanted to make sure that those environment variable values were exposed via the Microsoft.extensions.configuration standard that we were using previously when all this code was running locally inside Kubernetes. Oh, running inside a local Kubernetes cluster. And then down here, we go ahead and bind all of our service dependencies. So I've got some extension methods for doing things like configuring InfluxDB, for instance. Well, what we're going to go ahead and do here is I'm going to say get required service I configuration and get required service I logger InfluxDB client. So these service objects have already been bound by the time the function that calls this one has been instantiated. So I'm going to go ahead and use the Microsoft.extensions configuration standard to go ahead and retrieve the connection string for talking to Influx. We're going to go ahead and use that to retrieve the bucket, which is the equivalent of the database in InfluxDB, the organization, and then finally, we're also going to grab our authentication token. That token is scoped to only allow reads and writes into the bucket that has all of our KPI data in it. So I can't do anything like create a new bucket or any of that stuff in here. And I'm going to go ahead and pass those options in, use that to instantiate InfluxDB. And I'm going to go ahead and return this as a singleton instance that anyone can use. This InfluxDB client actually creates its own HTTP clients behind the scenes. Plus, this application isn't very long-lived, so we don't need to worry about resource leaks behind it, as far as I'm aware anyway. If you understand differently, please go ahead and let me know in the comments. The rest of our services, things like, let's say, well, I don't know, web analytics. So I go down here. This allows us to go ahead and get access to our Google Analytics data, all that sort of stuff. So I can go ahead and initialize a service account that's basically authenticated against all those, authenticated against our Google Analytics web properties. So this allows me to go ahead and query data from each of them. I have to go ahead and pass in a little private key down here to do that. And this allows us to instantiate this analytics reporting service. And then I have a little configuration object that's going to try to grab a list of sites that we want to inspect. It's going to iterate all of those and produce a little array of here's all the different properties you need to get data for when you connect to the Google Analytics service. And that is all configured. If I take a look at local.settings.json right here, this is basically a way of kind of telling the Azure Functions emulator that kind of runs locally of what to expect when you're kind of up and running in production. So down here, we have all these same environment variables in our production Azure Functions account, and I'll take a look at that in a minute. However, this connection string and this token are the values that we produce when we go ahead and run our little local Kubernetes cluster that contains a default Azure instance, and it also contains a default InfluxDB instance we can go and talk to. So we're actually using, like you can see here, this is a local Azure storage account. We're not actually talking to a cloud-hosted version of this yet. So that's all sitting in there. Next, I have my Google Analytics service account. So this Google Analytics reader at Psychic City, blah, blah, blah. This is just an email address that Google's Cloud Console generated for me dynamically. So I'm connecting to that, authenticating using that. And I also have a Google Analytics key that I can pass in via a .NET secret on this system if I want to go ahead and authenticate locally against the Google Analytics API. So this value actually doesn't need to be kept around. I can delete that. Then down here, I have this array. This is using the Microsoft.extensions.configuration syntax of saying, like, I want to create an array of these site objects. Each site object has a view ID. This refers to basically the Google Analytics view of that data. And that's the object we have to go ahead and query in order to actually retrieve daily, let's say, session data and all that stuff into our site. And then I also want to go ahead and correlate this view to a specific domain name, because here at Petabridge, we have multiple web properties that we keep track of. We keep track of the official Akka.net website, the main Petabridge website, and then we have a couple of websites for some of our products like Phobos and Petabridge.command. So we want to be able to go ahead and query all of these and get data for each of them and index them accordingly to each domain. So this configuration allows us to go ahead and do all of that. And in fact, if you go to our link for the service up here and you scroll down to supported data sources, I have a link right here that explains a lot of what I just covered in detail. Goes and talks about basically how you need to go ahead and authenticate against each of these services and how to set these configuration values inside Pulumi. So we have quite a bit of detail that explains how to do that in there as well. And I'll go ahead and drop a link to this in chat. Now, if I go back to the README, I walked through how to go ahead and host all this from scratch. The number one thing I kind of want to walk through today is a little bit about how to use Pulumi to go ahead and build cloud infrastructure for doing this stuff. Because that's kind of the most amazing part of this. The Azure function is really simple. InfluxDB is really simple. Those parts of the system you can probably grok on your own pretty easily. Pulumi is really the amazing piece. And that's what I want to spend a little bit of time talking about. So, what is Pulumi? Let me pull this up. So, this is one of these infrastructure as code platforms, and there's a ton of them out there. Terraform probably being the most well-known. I personally like Pulumi because I never learned the Terraform syntax. I gave Terraform and Puppet a try a number of years ago when we were trying to build continuous integration agents for TeamCity programmatically using those tools. And I had a hard time kind of reasoning about it. It seemed like just intricate sort of, let's say, third-party JSON to me was kind of what the working with the Terraform language felt like. Pulumi allows you to go ahead and write little programs that can help you build your cloud infrastructure up from scratch using C#, Python, Go, or TypeScript. So this kind of is more my speed, and we've been using Pulumi to go ahead and orchestrate fairly complicated cloud deployments, including things like SDK bin, for instance, is all orchestrated using this behind the scenes. And I think this is an amazing technology. It's very easy to go ahead and get started with it. There are free plans you can go ahead and use as a solo developer. Our team is pretty small here at Petabridge. We only have, it's only a few of us who are kind of working here full time. So I was able to get, I think, in terms of the pricing plan we're using, I think we're on the $40 or $50 a month plan. So, and that's free for unlimited projects. They price based on the number of seats you have. And then there's different editions, and like the more expensive editions of Pulumi have features in it like gating, where they can go ahead and say, hey, this person tried to make a change to the SQL database permission structure. You actually aren't authorized to do that, and we're going to go ahead and stop your Pulumi preview or your PulumiUP command from going through. So let's go ahead and take a little look at some of the Pulumi bits here. And I guess the first thing I should really go ahead and start with, let's just go ahead and open up a new shell here. And I'm going to go to my KPI dashboard. Let's see. I think all I've done is change my local settings, so that should be okay. Our Pulumi, let's say infrastructure, is all hosted. If I go to the source folder, it's all hosted inside this petabridge.collector.infra. And you can go ahead and take a look right away here at, let's say, pulumidev.yaml. And this is kind of like a mock YAML. Well, this is a real YAML file, but I just removed all of our values out of it. So the first resource that you kind of need in order to get started with Pulumi is you have to create what's called a Pulumi stack. So I went ahead and I created a fake one right here. And let's see, I'm going to go ahead and in another window here, I'm going to go ahead and log into Pulumi real fast, just so I can show you what a real stack actually looks like. Okay. All right, yeah, this looks good. All right, we'll pull this up. So you can go ahead and see a couple of our stacks that we have up here, the total number of resources. So let's say our Azure resources that we had back in March, 377. That's not just Azure, by the way. That's also Kubernetes resources. We also manage some resources in Cloudflare using Pulumi as well. So, for instance, we go ahead and manage things like our IP addresses not our IP addresses, our DNS information is all kind of managed through Cloudflare. And we have different domains for different environments. Some of them have, let's say, like Azure Active Directory control enabled, where this domain actually can't, let's say, resolve unless you're logged into our Active Directory network. That's part of Cloudflare. Cloudflare Access is the name of that product. So we go and configure all of that through Pulumi. But let's take a look at our petabridge.collector.infra stack right here. I can take a look at, let's say, all the different little values that are in here. And so let's say our secrets, by the way, you see these here. The configuration values were all encrypted and they're all stored up in Pulumi's cloud. So even though I'm the one who set these values, I actually can't go through and see what any of them are. So it's pretty nice. And so the only values we really have encrypted are our Azure API, MailChimp API key, InfluxDB token, and our Google Analytics key. Everything else is just a configuration value and is safe to kind of leave out via plain text, basically. And you can go ahead and see, last time this stack was updated was 3 days ago. We can see that it's a .NET project. And if I want, I can take a look at our activity and see what we've changed behind the scenes here. So I can go ahead and see, for instance, that I made our Azure tenant ID is now configurable via the stack. That's because we're actually doing a fair little bit of Azure permissions work underneath the covers here. So let's go ahead and take a look at the Pulumi CLI real fast. In fact, I'm going to open a second tab here. All right. Repositories. Stenardian. API dashboard public. All right. What files are modified? Metals. I think Metals is a plugin for doing Scala in VS Code. I think that's where that came from. All right. So if I go to source, petabridge.collector.infra, the first Pulumi command, and by the way, you can install Pulumi using Chocolatey on Windows, is I'm going to do Pulumi stack ls. This tells me that I don't actually have a stack at all inside this project. So if I wanted to create a new stack, I could do Pulumi stack init, and I can give it a name. I'll go ahead and call it dev. All right. And so now if I do Pulumi stack ls, you'll see that I have a stack just called dev. And I can go ahead and see basically all the information about the stack by going to this URL if I want. So let me go and type that out. All right. And so far, in my little dev stack, I have no resources. I have a little bit of metadata here, but that's pretty much it. Nothing super out of the ordinary just yet. Well, if I want to go ahead and start, let's say, building a real stack with Pulumi, I actually need to go ahead and code a little Pulumi program in order to do that. So there's a couple ways you can go ahead and get started with it. One is you can go ahead and just install some of the Pulumi NuGet packages. So if I go to our infra project, you see that I've installed the Pulumi.Azure native plugin and the Pulumi.Azure plugin as well. So the Azure native plugin is the one that Pulumi is strongly recommending today that people use. But I've run into a lot of trouble modifying existing resources with it. A good example, I found that it's very difficult to go ahead and create a new access policy for Azure Key Vaults using the Azure native driver. Whereas using just the Pulumi Azure driver, it's pretty intuitive to go ahead and add a new access policy. So the difference between these two is that the Azure native driver is using ARM to do everything, whereas the Pulumi Azure driver is actually built on top of Terraform. That's kind of the difference between these two. There are some things that are easier to do via Azure native. I think in particular, it's been pretty easy to go ahead and create new resources from the get-go with it. But this driver still appears to be a lot better at modifying existing ones. And then we have to go ahead and actually go about creating our stack. Now, when I do stack init, Pulumi will go ahead and usually create one of these for you out of the gate. Or it'll go ahead, if you do Pulumi stack init, it'll just create a new configuration. You can have multiple configurations for the same code. So for instance, on SDK bin, we have a development, QA, and staging stack for each project. And so those projects all use identical C# to go ahead and specify how to build and construct resources, but they use very different configurations because we're running in different environments. So the number of replicas might be lower, the DNS settings might be different, the amount of resources we provision might be different, and we might do things like provision a database at a lower pricing tier inside our development and QA environments versus our production one. Those are all things you can make configurable through the Pulumi configuration here. So we're going to set some commands in a little bit to actually configure Pulumi, but this is kind of what the output. So we already took a look at this kind of on the Pulumi website. This is what the output from setting Pulumi configuration looks like. You have a domain, petabridge.com, a view ID. These are all of our Google Analytics properties we're going to read here. I have our InfluxDB connection string, which is just the data center where we're in. We have our organization, our bucket. But then you'll notice we have this sort of secure token down here. One of the things that happens each time you go ahead and create a stack. Oh, geez. Yeah, no thanks, dude. Keep the bots off the channel, please. One of the things that we're going to go ahead and do is actually configure some Pulumi secrets here. What happens is that each and every time you go ahead and instantiate a brand new Pulumi stack, Pulumi is going to go ahead and create, using their secrets provider, a new private key. That's going to go ahead and encrypt all this data for you. At the time you read those values out during deployments, Pulumi will decrypt those private key values only during a deployment is when that's going to happen. So this is kind of what we set here, and I'll show you how to configure some of those in a moment. But then otherwise, I have my little Pulumi stack right here that's going to go ahead and allow me to describe an app service plan, blah, blah, blah. Rather than walk through what I have right now, let me show you how I went about creating this Pulumi stack in the first place. So I've worked with Pulumi both ways, where I've gone, oh yeah, I'm sure I'm real famous, H3. I've worked with Pulumi both ways, where I've gone and kind of worked from the ground up, building everything step by step using Pulumi and doing a lot of testing and so forth. I've done that. I think a better approach is to do what we tried to do last time, which is to manually go ahead and create all the resources you want to have in Azure. Try to go ahead and configure them the right way, validate that that configuration works. So for instance, in this case, I want to go ahead and validate that my function actually runs and can read all the secrets in Azure Key Vault. You go ahead and you do all that stuff first, and then you go to your resource group and you click Export Template. And I'm going to go ahead and uncheck the Include Parameters box right here. All right. So I'm going to go ahead and generate a template. And this will take just a second. So Azure's going to go ahead and produce a brand new ARM template for me. All right. Now this ARM template is going to go ahead and have things like, my tenant ID for Azure Directory in here. It's going to go ahead and generate some relatively hard-coded names for some of these objects. It's actually going to generate the current names for there. If I really want, I can go ahead and parameterize this. So let me go ahead and copy this. And I'll go ahead and get a window open here. We can take a look at it. Now, let me go ahead and roll that over just a little bit. So a lot of the stuff that the ARM template's going to give you is kind of like boilerplate crap we can get rid of. Good example, this Microsoft.alert smart detector rules. These get created for you automatically every time you go ahead and deploy let's say, an application insights account, or you go ahead and tie the application insights account to an app service plan. You actually don't need this stuff inside Pulumi. So we're going to go ahead and delete this a little bit later. So let me go ahead and copy this for now. And now Pulumi, one of the great tools that it has, I'm going to add a little checkpoint right here. Go ahead and call this Pulumi. Yeah, we'll go ahead and call this ARM to Pulumi right here. All right. So I'm going to create a little checkpoint in the stream. So one of the things that's really cool is you can export that ARM template and turn that into a Pulumi application. It's just this little web app right here that's going to do it. So I'm going to go ahead and delete this really simple sample one they have here. I'm going to paste in my more complicated one, and then I'm going to press convert. That's going to run. Now it's initially going to generate a TypeScript one for me, but I'm going to go ahead and change this over to C#. Okay. Now let me go ahead and copy this, and I'm going to go ahead and paste it into a new stack. Okay, let me go ahead and save this real fast. We'll go ahead and call this C. Oh, not C. C#. Call this new stack. .cs. All right. Now they mention in here we're unable to convert your code completely. ARM to Pulumi will get you, let's say, 80% of the way there, but not 100% of the way there. So we're gonna have to do a little bit of work. So first things first, this application insight stuff. So we're going to go ahead and require a resource group name as a parameter. So this is one of the things generated by the stack. So, okay, that's actually good. It means that the resource group isn't going to be created by Pulumi in this instance. In some of my applications, we actually do create the entire resource group, but that's not always necessary. So the first thing I'm going to do is I'm going to go ahead and delete some of these properties I don't think we need to specify. If you don't specify the resource name, Pulumi will go ahead and automatically generate one for you. Flow type, blue field. I have no idea what that is, so I'm going to get rid of that. And then the other thing is, there's a couple different namespaces internally inside Pulumi for different versions of their .NET native, their Azure native product, and this really only shows up in the C# API. I always delete this stuff. That way we're always using whatever the latest stable version of this is. So I try to clean that up when I'm doing it. All right. So that looks good for defining app insights. I'm going to go ahead and just rename this down here, app insights. And Pulumi will generate a unique resource name for this on its own. Now, I'm going to go ahead and delete. These are all these crazy detection rules that got generated by the ARM template by default. I don't need any of this. So I'm going to delete all that. Those same rules will be created automatically whenever I mint a brand new, app service plan or Azure Application Insights resource. Next, I'm going to go ahead and trim this part of the namespace off again here. Do that down here as well. Okay, that looks good to me. Now, once again, we're taking all of the possible, let's say, bells and whistles from ARM and turning them into Pulumi settings. You probably don't need to specify all this stuff. Like, do you need to specify this is a Hyper-V app service plan, or it's a Spot plan, or it's Xenon? No, you don't. Go ahead and just get rid of it. Maximum elastic worker count 1. I'm going to get rid of that. Don't think I need to specify it. I'm going to go ahead and get rid of that as well. And then finally, I'm also going to go ahead and I think I'll keep the family name and size and the tier for this. I think I do need some of that. Some of this I actually can get rid of though, so I'll leave that there. Target worker count, target worker size ID, don't need that. All right. So this creates our app service plan in Pulumi. This is basically going to be our billable unit for running our Azure function. The next thing Pulumi is going to try to create for us is the actual Azure function itself. So once again, in fact, the other thing I'm going to do, by the way, I'm going to go ahead and rename this to just KPI Linux. And I'm going to rename this function to KPI Collector. Pulumi will come up with unique names for all these resources. I'll go ahead and delete this bit of, let's say, extraneous namespace from Pulumi here. So I'll go ahead and get rid of that. I'll get rid of that. Let's see. Actually, you know what? These hostname SSL sites, these are all default Azure host names. If you needed to specify a custom host name, you might need to fill this out, but otherwise, no. So I'm going to go ahead and just delete this entire section. Plus, we're actually not even using HTTP in the system. So I'm going to delete that. Redundancy mode, none. Going to delete that. Name, going to delete that. I should also delete the name from here. That value will be dynamically generated. Now, the one thing I actually don't see right here is I don't think they specified. They say this is a function app and that it's dynamic, but I actually don't think Pulumi specified this is Linux. So in that case, Nope. Actually, this looks fine to me. I guess I don't need to specify it. Okay. Well, I'll go ahead and leave that alone as is. Site config, don't need that. You actually do need this, the server farm ID. This is basically this web app's way of specifying what service plan it's going to be defined underneath. So we're going to leave that there. Reserved false, don't need that. Enabled equals true, redundant. Yeah, I'm going to get rid of all that as well. One thing I strongly recommend is if you don't need to specify it, then don't. Now here's one thing that's also kind of interesting. This custom resources option allows you to go ahead and specify things like explicit dependencies between resources in your project. Guess what? This actually isn't necessary, saying that, hey, this web app resource depends on our app service plan being created. I actually don't need to explicitly specify this dependency here because I already take a transitive dependency on the object right here. Pulumi's smart enough to know, based on the graph of all the different objects and how they depend on each other, in what order certain Azure resources need to be created in order to be deployed. So you actually don't need to go ahead and specify this. Your C# code will already go ahead and tell Pulumi what's up and what needs to be created first. So if I need to create, let's say, an app service plan, and then a web app, and then I need to create a web app function like this, Pulumi can figure out that the order for this goes 1, 2, 3, all on its own. So that's a very powerful feature of Pulumi, and that's one of the benefits we get from actually writing programs to go ahead and make our infrastructure immutable instead of using, let's say, configuration files. That's one of the really big benefits behind that. Oh, Pierre, thanks for following. I appreciate it. All right. Now, let me go ahead and trim this off again here. And we're going to be able to get rid of a whole bunch of crap out of this. So let's take a look. Okay, script ref, root path ref, all this stuff. You know, we actually don't need any of this at all. I don't need this. In fact, I don't think I need most of this stuff. By the way, this output from the Pulumi to, from ARM to Pulumi actually looks different than what I had before. Now, this is a little bit different. Now, by the way, what I have down here, this depends on KPI collector, blah, blah, blah. I actually do need this custom resource specification this time because none of these other properties actually depend on this web app here. So without having this bit of code, Pulumi might try to deploy this web app function concurrently with some of the resources it depends on, and our deployment would fail in the event that that happened. So we want to try to avoid that as best as we can. Now it looks like we're creating some web app hostname bindings. So I think it looks to me like Pulumi might have, since like the past week where I did this, they might have actually released a totally new version of the Azure native library for this stuff. So at this rate, we've kind of talked a bit about, you know, some of the different things that Pulumi can generate for you if you try to import an ARM template and use that to generate your Pulumi program. Let me go ahead and show you what the for real Pulumi program looks like. It's actually pretty simple. So first, we are taking a look at starting exactly where we did before. We're going to create an app service plan. It's going to be a function app. I'm going to specify the resource group we're going to deploy into. I'm specifying, let's say, the pricing tier for this. So it's a Y1 pricing tier, and it's dynamic. And then the next thing we're going to do is we have to plan how we're going to continuously deploy into this resource group. Well, based on a bunch of these samples that are online, Pulumi has a ton of really rich samples, and there's a bunch of third-party ones that have been published by a lot of helpful people in the .NET community. And so now I hope I've just contributed another helpful example as well. I'm going to create a storage account down here, and that storage account is going to host the zip files that Azure Functions can use to go ahead and deploy these little applications every time we push an update. So I'm going to go ahead and create a new storage account. I'm going to create a new container inside the storage account. And again, because we have this transitive dependency right here, this guarantees that this account must be created before this blob in the account can be created. A blob container, excuse me. Then inside my container, I'm going to create a specific storage blob called my functions. And I'm going to go ahead and specify a reference to the container. And I'm going to create a file archive. And this file archive is going to go ahead and point to this function app publisher folder right here. This folder is basically a relative path from the folder where the stack is defined. This will walk back to where all my binaries are, where my Azure function lives. So the very first time we run this PulumiUP, we're actually going to go ahead and deploy whatever the release binaries are that are sitting in this folder. If this folder is empty, so meaning that you haven't run like a release command just yet, you haven't actually tried to compile your Azure function, this deployment will actually fail because the zip will be empty. And Pulumi is smart enough to tell that that's probably not what you want to do. So this blob is going to contain the first version of our application. I'm going to talk a little bit about the continuous deployment aspect of this in a second, but basically the way we're going to continuously deploy this function is we're going to be constantly replacing this blob with a new blob. And what we're going to do is essentially tell Azure Functions that, hey, rather than using this old blob, go ahead and use this new one instead. And that allows us also to do rollbacks if we want to, because the old blobs don't get deleted. They just kind of stay there and will only get deleted if I manually go through and do that. So that's one of the things that's pretty cool about this. Next, I have a little function. I borrowed this from one of the Pulumi samples. That's going to generate an SAS signature for being able to get read-only access to this blob. Azure Functions actually needs that to be able to go ahead and deploy this app. So if I go down here, this code was all originally written by the Pulumi team in one of their public code samples. So what I'm going to do is take my blob that I created before. I'm going to pass in up here. So I'm going to pass in my blob container, and I'm also going to pass in a reference to my account. This output decorator means, by the way, that this string value will only be populated after this resource has been deployed. So this is kind of like creating a task in Pulumi, specifying this output bit here, that this value will only be populated once Pulumi has been able to successfully deploy that resource. So this output.tuple command is kind of like the equivalent of a task.whenAll. So I'll go ahead and comment that here. That it'll only complete once all these different resources go ahead and fully instantiate. And so we're going to go ahead and pass all those as a tuple together down here. I'm going to go ahead and deconstruct that tuple down to its component parts. And then I'm going to go ahead and basically invoke a little function on Azure Blob Storage to create a special access signature right here. I'm going to go ahead and pass in the URL. And I'm going to go ahead and return this as a basically as a simple URL that I can pass into my Azure function right here. So I'm going to go ahead and return this way. And then if I scroll up, let me grab it real quick. Yeah, if I go ahead and I scroll up here, back to where we create this, I'm going to pass this code blob URL. If I go ahead and go to find references, it gets passed into my Azure function down here. And this is basically to tell Azure Functions, hey, you need to go ahead and run, whenever you get invoked, you need to run using the data that's stored inside this blob URL here. So this is going to kind of set the stage for us to do continuous deployment in a little bit. So that's the first portion here. Now next, I'm going to create my app insights component. And then the next thing I'm going to go ahead and do, I think I ultimately had to scrap this. So this resource actually isn't doing anything. But one of the things I need to go ahead and configure is if you want to create an Azure Vault that stores all the sensitive information you don't want people on your team or end users to be able to access directly, and you want to store that information securely, Azure Vault's a really good way of doing that. But one of the things you need to configure is you have to create a Vault access policy that allows your application to read what's in the vault. And you have to be able to go ahead and specify, hey, I have the ability to read secrets, but not to create them. Or I have the ability to query a specific secret version, but I can't get a list of all the versions of that secret that there have ever been. So you have to go and create an access policy. In order to be able to tie those two bits of infrastructure together in Azure, you have to create an identity for that. And there's two ways you can go about doing it. One is you can create a managed identity, which means you as the end user are creating a fictional service account that basically is going to represent some unit of authorization. And so that's what a managed identity is right here. The other way you can go about doing that is certain resources within Azure allow you to create what's called a system identity, meaning that behind the scenes, Azure will automatically go ahead and create a object in Active Directory that is associated with whatever this piece of cloud infrastructure is. That object could be an Azure function, it could be an AKS cluster, it could be any number of things. So I tried to create a managed identity right here, and I wanted to go ahead and basically say this managed identity has these types of read permissions from Azure Vault, and I'm going to assign this identity to the Azure App Service plan that's going to read from the Vault, and that'll go ahead and tie everything together. That didn't work because the Pulumi syntax for assigning a managed identity to a resource is extremely convoluted in C#. I'll go ahead and link to the open GitHub issue we have on it, where a member of the Pulumi team very helpfully showed me the right way to do it. But by the time I got that information, I already had the second approach, which is to use a system-assigned identity working. The trick to kind of working with a tool like Pulumi is you just got to do a little bit of trial and error and kind of discover what works and what doesn't. Because there's all sorts of quirks that have nothing to do with Pulumi and everything to do with what Azure expects. So the first thing I'm going to do here is I'm going to create an Azure Key Vault, this KPI vault right here. And so inside this vault, I'm going to go ahead and specify a default access policy for our managed identity. And if I take a look at this, I just need to pass in the ID of that managed identity object. And I need to go ahead and say, okay, this object has the ability to fetch keys and to get secrets. And then I'm going to specify the tenant ID. The tenant ID is basically inside every Azure, so let's say organization, you get an Active Directory tenant ID that represents all the resources and users inside of it. You usually need to specify the tenant ID is like the ID of that directory. So that's one thing you need to specify here. Usually your organization only has a small number of those. Usually it's one. In really big companies, you might have one tenant ID per each independent Active Directory network inside your system. This is pretty simple to look up inside Azure though. In fact, when I exported my ARM template right here, our tenant ID was actually incorporated down here. Yeah, here's our tenant ID, for instance. So you can go ahead and find this. In MCS, that's Microsoft Consulting Services, we called it arm wrestling. That's funny. So this is our little access policy we're going to create here. Now, if I go back to the Azure Vault, let's go ahead and go back to our little function here. If we go back to our Azure Vault, so all we're going to go ahead and specify, you can grab the tenant ID from your client, from the Pulumi client. Yes, you can. I had some trouble figuring out how to do that, actually. I spent a couple of hours looking through the documentation for doing that. I knew how to do that for the old Azure provider, but not the new one. I did eventually find a bit of syntax that shows you how to do it later. So I basically worked around that by incorporating it directly into my stack configuration, but Piers is correct. You can go ahead and actually grab that information directly from Pulumi. It's going to use the same tenant ID that Pulumi is using to actually go and modify these resources behind the scenes. So the way Pulumi authenticates against Azure is Pulumi needs to run under the permission of a service principal that basically has contributor level access or owner level access potentially to the entire subscription. That's a little bit dangerous. That's also why the only way to do Pulumi deployments in our system is typically it has to be done through our CI/CD. That's the only part of our network that really has the ability to do that. Otherwise, someone could potentially blow up all sorts of different stuff inside our system. We also tend to use resource locks pretty aggressively with Pulumi. So for instance, we don't want somebody to be able to go ahead and accidentally wipe out our production database. Which is a thing these really powerful immutable infrastructure systems can do. That's also why Pulumi has their policy manager and gating controls. These are all designed to kind of help limit accidents that developers might make in production. Now, after we create our vault, we get a resource to it right here. The next thing I need to go ahead and do is I need to go ahead and actually create some secrets we can consume from the vault. So I wrote a little function in Pulumi right here called create secret, where I'm going to pass in the name of my secret. I'm going to go ahead and read from configuration config.require secret. This means what's kind of nice about this from a statically typed perspective is that if you haven't specified this secret inside your Pulumi configuration, your Pulumi preview or your Pulumi deploy operations will actually fail when you try to do this. So for instance, let me go ahead and comment out my news stack here, since I don't really want to use that right now. And let me go to, I think we're here. If I go ahead and try to do Pulumi preview, this should completely flame out on me. It shouldn't work at all. So Pulumi preview is a safe way of being able to go ahead and try to plan what your cloud changes might actually look like. So I'm going to go ahead and install. Looks like we have a brand new version of the Azure native plugin. Okay, that makes sense. And you'll see here, we're missing a required configuration variable. Stenardian.collector.infra.resource-group-name. And so these little function calls, we have config.require-secret, and a little bit further up here, we have config.require-resource-group-name. If you don't specify those values inside your Pulumi configuration, the deployment fails pretty quickly. So that's another good practice to kind of get into, is making sure that your Pulumi configuration enforces those assertions along the way to make sure that you have those values defined somewhere in your configuration. Otherwise, the deployment can't succeed. So we're requiring our InfluxDB token. And I'll go ahead and get into the details of this create secret method in a second. We also require our MailChimp API key and our Google Analytics key. And we maintain, by the way, this is important, we maintain a reference to all these secrets here, because we're going to use that when we actually build our Azure Functions configuration in a moment. Now, if I go to definition here, this secret is going to take a reference to the vault we just created. And I'm also going to have, let's see, the secret value, which is one of these outputs here, secret name, and then the resource group name. So when I go ahead and I create a brand new Pulumi secret, I pass in the secret name. I'm going to go ahead and pass in these arguments here. I'm going to specify the vault, the resource group name, and then I'm going to go ahead and pass in the value for that secret as well. So this secret will be stored securely. It'll be fully encrypted on Azure's cloud. And one of the things we can specify, if I go back to where we were calling this a little bit further up, is when it comes time to actually create our web app that's going to be responsible for hosting our Azure function, I'm going to say, okay, this is going to be a function app, and this function app is going to be running on Linux. I'm going to specify my resource group. I'm going to specify the app service plan this function is going to run under. And here's where the real meat of the matter comes from. Is we're going to go ahead and generate all these little configuration values that are going to pass in everything this function needs to actually do its job in production. So we're going to start with some boring stuff. The first is I need to pass in the primary connection string for our blob storage, because Azure Functions is going to essentially acquire a lease whenever it's using a timer schedule behind the scenes. It's going to go ahead and lease a blob inside that storage account. So we need to go ahead and give it a way to do that. Next, I'm going to go ahead and configure the runtime here. If you were trying to deploy, let's say, a Node.js or a Python function, you would go ahead and change this value down here. Most of this code, by the way, for deploying the Azure function is fairly platform agnostic. All Azure Functions is going to do is it's going to go ahead and take a look at the worker runtime. And then based on that, when it downloads your zip file and unzips it, it's going to go ahead and just try to execute a default entry point command using whatever runtime you specified. So all this code I'm showing you, even though it's deploying a .NET Core 3.1 function, can be very easily repurposed for other programming languages and types. Next, we specify what the initial package should be. Specify the Azure Functions versions down here. So I'm going to specify we want to use version 3. And then I go ahead and add some comments to kind of specify, here's our application insights, connection string, and instrumentation key. And then I'm going to pass in some of my other variables that are specific to my application here. So we're using the sort of environment variable syntax that Microsoft.extensions.configuration uses. So this will show up inside Microsoft.extensions.configuration as InfluxDB connection string. Oops. Like this. So we're basically kind of using that syntax so all those environment variables can be mapped this way. Because this is the format that our actual C# code expects them to be in. So I'm going to specify all this. And then here's where the really cool stuff comes in. We're going to go ahead and dynamically create a reference to our secrets we just created in the Azure Key Vault. So I'm going to go ahead and specify our InfluxDB token. And I'm going to go ahead and call output.format. This is going to asynchronously format this value after this resource has been created. So I'm going to go ahead and say, okay, our vault is going to be equal to the name of our vault, and that name is generated dynamically. And our secret is going to be equal to this secret name here. And this will go ahead and tell Azure Functions to try to authenticate against this vault and retrieve these secrets this way. And we go and populate the rest of our values pretty much this way as well. Now, here's kind of the last little bit of like practical production sort of details for the Pulumi bit, is actually authenticating against the vault and getting access to this privileged data. One of the things we're going to go ahead and do is I threw in the towel on trying to assign the user managed identity right here because the syntax, I spent like a couple hours bashing my head against the wall trying to figure that out. I eventually threw in the towel on it. And so what I decided to do instead is just have Azure go ahead and assign an identity to this object here. And so one of the things I'm going to go ahead and do is after this resource gets created, I can go ahead and say, I want to grab the identity of the KPI collector, this, let's say, managed service identity response. And I'm going to go ahead and take the principal ID and stick it into this string right here. Well, what I can go ahead and do is I'm actually going to use the old Windows Azure driver for Pulumi. I'm going to go ahead and say, I want to create a new access policy. And I'm going to go ahead and say the object is going to be equal to my app ID. It's going to have get permissions for secrets. And it's going to go ahead and use the key vault that we had earlier. So this is kind of the final piece I need to make sure that my Pulumi app can go ahead and actually authenticate against our Azure Key Vault. The last thing that I did that's in here is that system assigned identity idempotent, excuse me. Yes, it is. It's idempotent so long as you don't create and read it. As long as you don't recreate the resource, it should be fine. So if I go ahead and I delete the web app and recreate it, it'll very likely, in fact, I'm pretty sure it's 100%, will come back with a brand new system identity in that case. But yes, otherwise it is idempotent. For every single, let's say, if I go and make any configuration changes and I modify the resource without deleting it first, that identity will stay fixed. So yeah, but I don't believe those identities can get reused. That would be an Active Directory detail that I personally am not privy to. Now, the last thing I'm doing is we have this fairly complex piece of Pulumi configuration right here. This set of domains and UIDs. This is for querying our Google Analytics data. Well, trying to go ahead and read this data out, and here's the other thing. We actually don't know what the size of the array is. I could have 4 web properties like I do here, or I could have 40. And so rather than trying to write a manual, let's say JSON parser or something goofy like that, you can go ahead and just say config.getObject, and you can pass in a little POCO class that this will be deserialized into. So I created a really simple Google Analytics class with a list of site values, and then each one of these site values has a view ID and a domain. So this works for deserialization purposes. And then from there, I was able to go ahead and create a list of name value pair args that our web app expects. And I go ahead and I assign those up here in our app settings. So that's the entire scope of the Pulumi sort of application so far, in terms of all the little bits and pieces that allow us to go and create that infrastructure from scratch. Now, this is our public version of this code so far. And so I don't actually have a full-fledged Pulumi configuration here. By the way, I meant to include this from my show notes. Let me go ahead and grab those real fast. So we're going to move on to talk a little bit about how to actually continuously deploy this application in just a moment. However, you'll go ahead and notice that none of my deployments appear to be going through. That's because we're getting this error. No hosted parallelism has been purchased or granted. To request a free parallelism grant, please go to blah, blah, blah. I sent an email to, actually, you know what? I may have done that the wrong way. I actually did submit a parallelism grant, but I did it the wrong way. So this is a relatively recent change in Azure DevOps. Normally, they give you, I think, up to 10 parallel jobs for open source projects. At least that's what we have inside Petabridge and inside the Akka.NET project. We have that much. This recently changed. Now, why did that change? Well, it changed pretty recently. And it's because, how do I put this? My suspicion in terms of why Azure stopped making it so easy for people to sign up for the free tier for Azure DevOps. I strongly suspect this is because people were abusing it to mine cryptocurrency. That's what I think is going on here. Because this change happened earlier this year. Yeah, crypto jacking, as H3 said. We've seen this happen with GitHub Actions as well. People will send pull requests to go ahead and start using the build server to try to mine Bitcoin, stuff like that. So that, unfortunately, if you go ahead and make something plentiful and abundantly available without any restrictions on it, people will try to go ahead and strip mine it. That is what appears to have happened to Azure DevOps. So I applied for a free grant for my personal account. I already have some for my Petabridge organization, but that's why all my CI is failing on the public project right now. If I go back to the Petabridge version of this project, our CI is working just fine for the most part. So one of the things I'm going to go ahead and do is I'm going to go down to this update cron job to only execute once every 4 hours. I'm going to go ahead and update that. And I'm going to enable auto merge and squash on there. So that should go ahead and go through on its own. So that pull request will automatically be merged in on its own. Last thing I'm going to go ahead and do is we'll walk through the continuous deployment process in just a second. Let me go ahead and make sure. Oops. Git fetch. Go ahead and do that. That's what I meant to do. Go ahead. Update this. Okay. All right, so my local copy should be up to date now. Now I'm going to go ahead and do a little Pulumi update demo. I'm going to go ahead and show you an example of, let's say, trying to update, trying to go ahead and update this application via PulumiUP real fast. So I'm going to copy this. I'm going to create another new PowerShell tab here. I got made fun of for using Commander last week, but I love it. It's been my favorite CLI for a number of years. And I'm going to go ahead and change directories to petabridge.collector.infra. And I'll type in Pulumi preview on here. Now, this is actually connecting to our live Azure infrastructure now. So this isn't a toy. This is the real deal. So I'm going to do Pulumi preview. You didn't know that Commander existed and Windows Terminal's a ripoff of it? Well, that might be the case. I've not really looked at Windows Terminal much myself. I've been using this for, I don't know, 5 years. And it works great for me. I really like having the ability to switch between like Bash and Windows, WSL, all that stuff. Okay, so what can we see here? The first thing that's going to happen if I go ahead and try running PulumiUP is that my object ID might be changed, and my blob might be changed, and my site config might be replaced. So Pulumi is giving me a little preview in terms of what it's going to try to do. So I'm not going to go ahead and actually do a PulumiUP locally just yet. I just wanted to kind of go ahead and demo it. We're going to do that via Azure DevOps. And in fact, let me connect to the right project for this. Let's see, this appears to be my local one. Let me go ahead and do a reload here. And I'll go ahead and open this up. Now, if we take a look at, let's say, our build checks in GitHub, you can go ahead and see I've got some Azure pipelines checks here. One of them, if I go ahead and take a look at any one of these pull requests so we can see it in a little bit more detail, is I have one that's going to go ahead and run compilation, and it's going to go ahead and try to actually run into unit tests that are associated with the project. The second check is going to go ahead and run a Pulumi preview. And if the Pulumi preview fails, that's going to tell us that there's that we broke something in our Pulumi configuration, and it's going to prevent the pull request from being merged. So if I take a look at our most recent commit that was merged in, this one right here, and I take a look at this, this will go ahead and tell you basically what resource changes that this pull request is going to cause. One is that we're going to go ahead and create a replacement of our storage blob. That makes sense. Every single time you compile it, it's going to go ahead and create a new zip file. The hash is going to be a little bit different, and it's going to go ahead and cause that to create a new replacement. Plus, the blob that we're going to create is presumably a brand new one that is therefore different than the one that's currently running in production right now. It's also going to cause us to go and update the configuration of our web app to point back to whatever the previous Pulumi blob was. All right, so that's fair enough. So that pull request just got merged in via git auto merge. That's fantastic. Next thing I'm going to do is part of our release process is I'm going to update our release notes. Change this to May 21st. This is part of a standard build process that Petabridge uses in all of its projects. Even the Akka.NET project is released this way, where I basically have to manually go and type up some release notes down here. So I'll say, we updated to Akka.NET 1.420, changed cron schedule to run once every 4 hours. And let's see, are there any other important changes I made here? I don't think so. I'll grab a link to this one. Made tenant ID configurable. All right. And I can go ahead and link to this here if I want. Okay. I'll go and say added. And I'll create a new branch for this. Release notes 0.21. Proposed changes. All right. I'll go ahead and send that in. And then I'm going to go ahead and enable auto merge. So when all those pull requests, when all these checks pass, this will automatically be merged in. And that'll allow us to move on to the next stage of our release process, which involves actually trying to deploy this. Now I'm going to go ahead and click into Azure Pipelines here. And we see our pull request validation. You'll notice I have what's called a two-stage deployment job. Before the second stage can run, which is the Pulumi preview, the first stage has to complete. So, by the way, I wrote the entire deployment system using YAML, and that's all open source inside of this repository as well, which I'll drop another link to in chat while I'm here. So, the way this deployment process works is we're doing what's called a multi-stage deployment. Stage 1 has to complete before stage 2 starts. And stage 1 can have multiple jobs. So if I wanted to have, let's say, one stage for doing compilation, one job for doing compilation, a second job for doing unit testing, and a third job for doing integration testing, those could all be separate jobs that all exist inside this stage here. All right, so this stage completed successfully. We're just going to go ahead and complete everything. I think we're just doing Linux for this. Yeah, we are. And then the next stage, deployment, goes and starts. So this is going to go ahead. It's going to authenticate against Azure Key Vault in order to get access to our Pulumi API key. It's going to go ahead and have us log in. We'll take a look at the Azure CLI down here. We can go ahead and see basically like I logged into Azure using a service principal. All this data gets filtered out. Even though this is running in a private, a private branch right here, but all this data gets filtered out. So we have to log into Azure first before Pulumi can actually do its job. Next, we're going to run a .NET publish to go ahead and make sure all this content is in that folder we're going to bundle up and turn into an assembly. And then we run PulumiUP down at the end here. So that's our PR validation pipeline. And that's the continuous sort of integration piece right there. By the way, we don't actually run PulumiUP, we don't run PulumiUP, which is what does a deployment. We run Pulumi Preview, which allows us to see what one looks like. Our release pipeline has two stages to it right here. The first stage of the release pipeline is we go ahead and we basically authenticate against Pulumi, log into Azure, publish our code, and then we do call PulumiUP. So this is our last deployment, which I think we did, earlier this week. And you can see down here that we're deleting the original blob, replacing the blob. I'm creating a new secret, our Google Analytics key. And then I'm going to go ahead and update the config for my web application. So we have PulumiUP run first. So any configuration our application depends on automatically gets set and populated. So that's kind of the first stage of our deployment. If that doesn't succeed for some reason, then we don't actually want to go ahead and try to touch the actual Azure blob itself. Now, one small problem I didn't actually realize is that because of the way we built this Pulumi function, this is actually going to deploy a new version of the software anyway. So there is a chance we could end up with the way the system's designed right now, kind of borking our deployment. I guess we could go about fixing that if we wanted to by simply making it so the first time the site gets deployed, we go ahead and we specify like, I guess we wouldn't specify a blob. So the Azure function would deploy with no code and it wouldn't be able to run right out of the gate. And so we would go ahead and skip that whole blob SAS step potentially. That would be one way of kind of resolving that issue, so we're not deploying twice. And I didn't actually realize that until just now that we're doing this. The next bit down here, in terms of our stage, and I'll take a look at the YAML in a moment. All right, great. Looks like this went through. Now the next stage of our deployment down here is we publish the code, we archive all the files together into a little zip file, and then we go ahead and we publish a build artifact. Is what we're going to do here. So we're creating a little build artifact behind the scenes. If I take a look at our, let's see, it'd be in our build system folder. You can kind of see how this all works. So this is my PR validation pipeline. I describe my stages right here. Stage 1, testing. I use a standard pipeline template right here that basically just runs our little build.fsx file over here. We're using fake to actually go ahead and run our builds. So we're just running a little fake command that's going to run all of the unit testing and compilation stuff behind the scenes. Next, we have our deployment stage. I'm going to go ahead and pass in an access token right here. And I'm going to go ahead and run Pulumi preview. By the way, these different stages usually execute on different virtual machines. If you have multiple jobs that can all run in parallel, those will all run on their own virtual machines too, by the way. So resources you had here may not be available here. So just a little FYI about that. Next, we're going to go ahead and use some of our secrets from Pulumi. Let's see. So in this case, we're actually going to go ahead and log in using an Azure subscription service connection and Azure pipelines. We're going to go ahead and log in using that. I'm going to go ahead and set some variables that are running inside our task here. And Pulumi wants these environment variables kind of set in the background, so it knows how to go ahead and authenticate against Azure. That's kind of what we're trying to do here. We're going to go and then publish some source code, and then we're going to call PulumiUP down here. This is our, this is Pulumi preview, my bad. I keep forgetting that this is our, Azure pipeline, not our PR validation pipeline, and not our deployment pipeline. And then, let's see. Once all that's done, I'm going to go ahead and take a look at our Windows release pipeline right here. The way our Windows release pipeline works is we are keying off of the tag that someone pushes to GitHub. So if I go ahead and I create a new tag, which I'm going to do right now, actually, let me go ahead and grab, I think this is the right project. Yeah, go. Git checkout master dash any changes here. And let me go ahead and get rid of this new file that we don't really need or want. I guess it's just commented out. It's not going to hurt anything. We go to do fetch petabridge, git merge fxp, petabridge master. All right. Okay. I'm going to do git tag 021, and we'll go ahead and call this KPI.collector 0.21. Git push, petabridge, tags. All right. So this will go and push a brand new tag up to Petabridge's repository. Now, if I take a look at releases, here's what we'll see. We'll see a couple of releases that look nice, that actually go ahead and have, let's say, real release notes and have some assets we can download and all that good stuff. Then we'll see this one doesn't have any of that yet. These release notes, so these ones came from that file I just edited. The rest of these were automatically generated by Azure pipelines. And then on top of that, I also go ahead and bundle up the point in time, let's say, code for this Azure function, and I stick that as an asset onto this release here. So anyone on our development team who wants to go ahead and see what version of the code was running in production at the time this happened, they can go ahead and download it directly from here. And the best part is this code doesn't have any of our, let's say, private configuration values in it, because all of those are read via the environment variables we configure on Azure itself. So the code itself is pretty much neutral in terms of storing any of that. So if I go ahead and take a look at our release pipelines, we'll see that we're in the beginning stages here. We're going to do our PulumiUP deployment first. Let's take a look at that. Looks like we're in the middle of publishing some code. All right. While that's running, let's take a look at our release pipeline. So release pipelines, I know they were trying to make this supportable via YAML. I don't actually know if that's even finished or available yet. The reason why I like using release pipelines is it's very easy for me to do a rollback if I need to. That's one thing that Pulumi can kind of make a little awkward in some cases. As you can see right now, it's going to go ahead and deploy a new version of my software, and then we're going to deploy another new version on top of that. So we're technically deploying twice. Pulumi's a little opinionated about this stuff, and I don't like coupling changes in my cloud infrastructure to changes in my application software, and I demand that I have the ability to go ahead and roll back to a previous version of the software, even though the version of the infrastructure we're running on is the same right now. Because when crap happens in production and things are going wrong and I don't know why, I want the ability to do that. So that's why I'm using release pipelines here. So this release pipeline, if I take a look at it, is going to queue on this artifact that we're publishing, let's see, at the end of our release cycle down here. After I archive all these files together, and I'm going to go ahead and basically grab the system.default working directory, source, Petabridge KPI collector, blah, blah, blah. I'm going to go ahead and grab that same folder that Pulumi is using for doing our deployments. I'm going to go ahead and bundle all that together into a zip file that is named after the current build ID. And then I'm going to go ahead and publish this as an artifact inside Azure DevOps. I'm then going to go ahead and create a release. And I'm going to go ahead and take this same zip file and publish that in the release as well. That's also why I'm grabbing the release notes out of release notes.markdown down here. That's going to go ahead and use some GitHub credentials that I created to publish a brand new release on my GitHub account. One thing that kind of sucks, Azure DevOps typically authenticates with GitHub by being installed as an app, and that works amazingly well for most functions. One thing it can't do though is it can't publish releases. You have to create a separate GitHub service connection using OAuth to do that, or a personal access token can do it too. So I have a second GitHub connection that I'm specifying down here that's using my personal OAuth credentials to go ahead and publish releases. That's what it's doing there. And if you want to create a GitHub access token instead, you can scope that service connection pretty narrowly if you want. So the way this release function works is it's a very simple. I don't need to add any branch filters or anything else. I basically have continuous deployment enabled, and I'm looking from this build pipeline, I want to go ahead and grab the latest version of these build artifacts, and I'm going to give them a little alias /KPI release right here. I'm then going to go ahead and create a deployment trigger after each one of those releases. I'm going to go ahead and run this little job right here, which is to deploy a function app. And this is going to go ahead and basically override the exact same configuration that Pulumi set. And it's going to create a whole another little blob that I can deploy this application into in my blob storage account. That's what's going on behind the scenes right here. And that's what's going to be responsible for running our deployment, which is now happening right now. Now, this will only take, I don't know, maybe a little bit to complete. One thing I wanted to take a look at inside our resource group was, because part of like what makes this kind of a production-ready app is the way we're trying to hide confidential information from users of the system, from developers who are working on it. I wanted to go ahead and show a little bit in our configuration what our output looks like. So take a look at these guys right here. Let's see. We have our key vault reference for InfluxDB token. And if I click on this, all I can see is the key vault ID and the secret name. So even if I have the ability to go ahead and read secrets in Azure Key Vault with my level of permission, I can't see any of that right here. I'm going to have to go run a very specific command to try to go and deserialize any of that and decrypt it and store it in a way that I can grok what its value is. So this is a very safe way of being able to go ahead and take, let's say, business secrets and stick them securely inside your application somewhere. So if you don't see this little green check mark show up next to your key vault reference, this means you've got an authorization problem. It means that the service principal that's being used to authenticate between your Azure function, or really it's your app service plan, and your vault doesn't have permission to actually read these secrets. That's what that means there. But the green check mark means you're good to go. So that's what's going on there. Let's see, that's the wrong pipeline. All right, looks like we just finished creating our release down here. And this will go ahead and give me a little URL. I can see petabridge/KPI dashboard releases tag 021. So I'll pull that up. And lo and behold, I can see the release notes I typed up earlier. And I can go ahead and see my little zip file that has my function as well. So deployment complete. I'll go ahead and even kick off another one of these update jobs as well behind the scenes here. So I'll go ahead and have this update to the MailChimp SDK go ahead and run behind the scenes while I'm at it. All right. Now, if I go back to releases, we should see that this deployment is starting. Let's take a look at this. Initialize job. We're downloading our artifact. We're going to go ahead and connect to our little package here. That's going to go ahead and deploy. It's generating its own special access token for all this stuff. And yada, yada, yada. So that'll go ahead and complete successfully here. That should be wonderful. Syncing triggers for function app done successfully. Ta-da. All right, so our deployment is now complete. If I take a look at, let's see, some of our logs, for instance, or if I go ahead and take a look at our configuration. What's up? If I take a look at the website run from package, I can see that's the same special access token that was created via the sort of Azure Pipelines deploy right here. So looks like everything is up and running. I wonder if I can copy that value. Maybe I can't. Either way, that deployment has gone through. Now the rate at which our function runs should be reduced from once every 5 minutes to once every 4 hours. So that's great. I can always go ahead and change that again with a rollback if I really want to. So in fact, I might go ahead and do this here. I might go ahead and say, you know what? I want to go ahead and deploy this version of my software. Rollback. I'll go ahead and deploy that. Now, it might ask me to approve it since it's not running as a continuous deployment job. It's a manual deployment now. We'll see. So I'm going to go ahead and wait for the build agent to tell me what's up. But this should give me the ability to go ahead and execute a rollback if I wish. So let's go ahead and see how that goes. All right, there we go. Getting our queue information. All right, there we go. So it downloaded the old artifact. We didn't have to recompile everything again. All really what we're going to do is we're basically going to reset the configuration value of how this app is programmed. We're going to resync the triggers, and then we're going to go ahead and redeploy it. So that's one of the things I wanted to make sure that we had with the way we've written our software here is the ability to do a safe rollback inside our system. So I can see that this is the version that is now running inside production, inside our environment. So that's pretty much the gist of working with Pulumi and working with Azure Functions and doing continuous deployments using Azure Pipelines. I'm going to go ahead and try to get CI approved for this plan. So if users want to go ahead and submit pull requests or modify the service for their own purposes, they sure can. The last thing I guess I should probably show is that it is possible to locally test all of this. So if I go down to here Actually, I'll go to the public one. And I'll go ahead and change to our Functaculous right here. I went ahead, one of the things I typically have as a goal, so developing modern web applications is really nasty in my opinion, primarily because they take so many external dependencies that are very difficult to mock. Not just databases, but also invocations of remote cloud services, talking to third-party APIs, talking with other internal APIs. It can be very difficult to go ahead and orchestrate and test all that locally. So what I've found tends to work pretty well for us here at Petabridge is I'm going to go ahead and change directory here as well. Oops. I guess command to include an extra character here. There we go. One thing that I like, and we have some documentation that explains how to do this down here, how to build and run this locally, is we have a little Kubernetes set of service definitions that can all be scripted to start up using a little batch file here. That can be very easily rewritten to use bash instead. There's nothing special about it. We're not using really any batch-specific features. It's just what I have the most practice with. So if I do Kate's deploy all, like this, this is going to create a small little Kubernetes environment that's going to have Azurite. Azurite is a version of the Azure storage APIs that are all hosted inside a self-contained Docker container that runs on Linux. So I tremendously prefer using Azurite over using Azure's storage emulator. It's much more lightweight in my opinion. We're also going to go ahead and install an InfluxDB 2.0 instance and a little Grafana instance for trying to visualize some data. Is this running in Minikube? This is running in whatever Docker for Windows orchestrates locally. So if I go to Kubernetes here, and let's see, let's go to my dashboard. So I'm not sure what Docker for Windows runs internally. I don't know if it's Minikube. Could be, but I think it's just a local Kubernetes orchestrator. Yeah, don't totally know, but it works well enough for me. You can go ahead and see all the different little internal containers running here. And this is all going to get deployed, by the way, inside, let's see, all going to get deployed inside their own namespace, the KPI collector. We do this, we always use a namespace in order to make it easy to clean up resources when you're working locally. So I go ahead and do kube control get all n KPI collector. I go ahead and say, it looks like InfluxDB restarted. That can happen sometimes. But it looks like everything's up and running. And I can go ahead and see all the ports that these services are running on. So Azurite's running on port 10,000. Grafana's running on port 3,000. Influx is running on port 8086. And let's see. You know what I didn't specify? I didn't specify the login credentials for logging into Influx. So let me do that real fast. Let's see. Log into Influx with username. And I think if I take a look at my Kubernetes files in here, InfluxDB service, it's admin, password is admin 2021. All right. Added InfluxDB login. Oh, I gotta do this actually for Grafana too, now that I remember. I think the password for Grafana is admin. Well. Alright. Let's see. There we go, that was good. Alright. Admin 2021. Sign in. Buckets, we have our KPI DB bucket running locally. And I also have a token for admin here, which I can copy. And it's this, I pre-programmed this, something simple. All those values for all this infrastructure, that's all running inside Kubernetes. All those values are all hard-coded into the Azure Functions local.settings.json. And I did that on purpose in order, well, this is my private version of this, but you get the idea. I did this on purpose in order to try to make it relatively easy for users to go ahead and get the service up and running without needing to deploy it or create a whole bunch of infrastructure. Local testability is important on our team. So I can go ahead down here, and I have a little guide that explains how to run this locally. I think it's func host start. Yeah, here we go. So I'll go ahead and run that. So this will go ahead and compile the project, and this will fire up the Azure Functions emulator locally. Whoops. What is going on there? Well, I apparently have a compilation problem in the public version of this. Let me open that up. I think it's because I deleted some of the files that were extraneous and not needed anymore, and I forgot to remove that. Yeah, I did. All right. Let me go ahead and do git pull, git checkout B, fix, remove unneeded config files. And I think I just need to do, yeah, I think my problem was this and this. That should fix it. Let me go ahead and give that another try. Right. Now this should error out because I actually haven't set any .NET user secrets. If you want to try to emulate the function locally, you still need access to some of those API credentials, but I haven't actually specified any of them. You can get all of this working. If you take a look at my little guide right here on how to configure your providers, this walks you through basically how to go ahead and get access to all the API keys and everything else you need, how to set those configs in Pulumi, but it also explains locally how to use .NET user secrets and local settings.json to configure all this stuff. So if you want to go ahead and simulate all this locally and you don't want to accidentally commit any of these credentials into your repository, you'll want to go ahead and use this stuff. That's kind of the way to do that. Now, if I take a look at our output down at the very end down here, I can see that we've acquired a host lock lease. That means that our Azure function has been able to successfully authenticate against Azurite, which is good. So that means that that part of our system is up and running. And I think this is still running on a 5-minute timer, so that might take a little bit longer than we would like. I'm going to go ahead and actually quit that. I'm going to go into my function KPI collection. Let's turn this down to a 1-minute timer instead. And let's go ahead and restart that. Now, for those of you who are expecting a little bit more Scotch in this .NET Scotch edition, apologies for that. Last night, when we tried doing our regularly planned stream, I enjoyed a very nice glass of Ledaig, which is a delightful Scotch from the Isle of Mull, aged in sherry oak casks, 18 years old. Has a lot of peat in it, since it is a peated Scotch, but it's also aged pretty close to the water. So it has a nice hint of iodine in it, lots of powerful but contrasting flavors. All right, so here we go. Error while creating instance of Petabridge KPI collector web analytics actor with 0 args. And the reason why is because these parameters that we were looking for to try to go ahead and actually configure our service weren't found. So we'll go ahead and see these errors get logged and the function will go ahead and exit. So that'll go ahead and do it for today's makeup stream. So thank you very much for watching today. We really appreciate it. Please go ahead and fork the code sample and play around with it if you have any questions. This definitely won't be the last time we go ahead and do Pulumi. And you can also expect a blog post from me coming up soon that'll go ahead and cover this in a little bit more written detail. So hey, thanks for joining us today. Really appreciate it and hope you all have a fantastic weekend. Thank you very much.